So it's been a tradition on my channel to make a kit, a Christmas themed kit. Now I know it's not Christmas any longer, but I was not making videos for a few months, so but I did buy this kit and I would like to make something. So despite the non-seasonality, I think I might press ahead. So you can see from the PCB here that this is like meant to be a Christmas decoration, Christmas tree decoration. So it's got Merry Christmas on it and reindeer and other themes. You can see that LEDs go around the outside of the board here. We've got some load resistors, and in the middle the venerable 555 chip. So it's some kind of timing, flashing type effect. I don't know what. There wasn't a demo on the website. And on the back you've got space for the two battery holders. So some kind of disc battery goes in there. And there's even some instructions, which, as you know, is not always the case with these Chinese kits. So the manufacturer, Dicavs or Dicavs, I don't know. There's a lot of strange names in these Chinese companies. So there's no actual instructions. It's just like a manifest of parts. Oh, there's a switch there as well, so you can switch it on and off. And oh yes, so it has some Christmas focused accessories. Let's have a look. Resistors, 555 switch. Here we go. So we have a little chain for hanging it up from the tree, and a Christmas ribbon. So again, themed with Christmas baubles, stars, presents, Christmas trees, reindeer and so forth, but quite a nice green Christmas ribbon nevertheless. So those are the load resistors for the LEDs. 1K it says. There's no circuit diagram, is there? So we can't really infer what it does. Oh, that's a 10K resistor. Where does the 10K go? Oh, it's there on the 555. So it's to program the flash rate of the 555, basically. So I guess the starting point then is these 1K resistors. So let's put those in. I guess you could even put them on the back if you wanted to, but I shall fit them as specified. I'll just put them all in, bend the legs to keep them in place, and then I can solder them all in one go, can't I? So there we go, that's all the ones around the outside. So there's a 1K on the 555. And also single 10K. There we go, all the resistors in place, and I've got a few spares for my bits box, which is great. So let's fire up the old soldering iron and get those into place. I haven't actually done any soldering in some months now. As I said in the last video, I did move house a few months ago. A lot of things were packed away. Well, a lot of things still are packed away because we're going to do a bit of building work. So there's not really room in my house for the lab at the moment. So I hope you can be patient with me. I do have a few projects lined up. It's just a question of when I can get to do them in front of the camera. Oh, by the way, since last year I actually crossed another threshold, so I've now got over 4,000 viewers to the channel. So thank you very much, everyone. Thanks for sticking with me if you've been with me all along, and if you've recently joined or stumbled across my channel, welcome, and thanks very much for your interest in my my hobbies, my electronic experimentation. I have missed a chance to do a few things in front of the camera. So for example, I recently fixed a Nest thermostat where a battery had leaked and destroyed a wire. I mean, it was quite a trivial fix, but you know, these things can be expensive to replace, so it felt worthwhile. But I'm sorry that I didn't capture it in front of camera, because, you know, it seemed more important to restore the heating for my friend, really. Right, let's find some clippers. snips. Is that the correct term? I'm not sure. Is that one soldered? There's a blob there. Yeah. Okay. Right, I think there's some solder on all those points. So, what next? LEDs, I guess. There's nothing in the instructions, but I'm guessing that alternating is what's planned. So there's a flat spot marked on the silk screen here, so we have to match that with the flat on the LED. Actually, do these LEDs have any flats? Right, it wasn't that easy to see, but actually there is a flat, but it's on the same side as the short leg, so I need to put the short leg towards the outside, I think. Oh, here it's not the outside, it's upwards. So let's be a bit careful with that. Whoops. Right, so all the LEDs are in place, and let's try and get them all sort of snug for soldering. And I've got, once again, a few spares, 2 of each colour. All good kits come with a few spares. Okay, so all the LEDs are in place, and so all that remains is capacitor, 555 and switch. Just solder one leg so that I can make sure it's properly positioned. There's no socket for the 555, but I do have some spares if something goes wrong. So. Okay, so those pinholes did seem slightly wide. That's quite difficult to get all those legs in. I managed to tease it in, I think. Just make sure the legs are all showing. Yep. And the capacitor, make sure, because it's electrolytic, got to make sure that the negative is in the right hole. Good. Right, so we've got to put these battery holders in. So the battery holders, it's kind of indicated that they go on the back, so we can do that. But once again, they have to go the right way around. Oh yeah, so the rectangular bit is indicated. You see, it doesn't want to sit flat because of the ends of the resistors sticking up. That's a bit of a design flaw, but there we are. I think we might have to have it slightly wonky. So it doesn't want to sit exactly flat, but that'll do, I think, as long as it's electrically good. Perhaps these resistors would be better if they were soldered from the top. So there's a top tip for you if you make this kit. Put some of those resistors in last. Oh dear, connector just fell out. Okay. Be careful with that one because it's not fixed, it's only really held in place by the solder. There you go, it's not flat, but it's rugged enough, I think. Right, so you can see if we can find some batteries. Right, got a few batteries here, none of them are new, but let's see what we've got. Right, that one's reading 3 volts, that's all right. 2.5, 3. There we go. There's a couple of 3 volts. Oh, there we go. So it's alternating red and green. That's the pattern that they're going for. So I could probably take a guess at the circuit diagram of this now, knowing what I do about the 555. So perhaps I'll just sketch something down. So I haven't buzzed the circuit out, but this would be my guess as to the circuit diagram. This is a fairly standard layout for the 555. So in terms of how the LEDs connect, the important thing here is the output pin here from the 555. You've got a set of LEDs which are going to light when the output is high. I'm not sure which is red and which is green, but here we go. So when the output is high, the current flows through the several different LEDs. How many are they? 1, 2, 3, 4, 5, 6, 7, 8 of each colour. So we've got eight of each colour, and yeah. So when the output is high, all of these light together. Each one has its individual 1K load resistor, which is quite a nice pattern for LEDs, which can vary in brightness even in the same batch. And then in the other half of the cycle, when the output is low, current will flow from the power rail through the LED and the load resistor to the output, which is now to ground. So that in this other cycle, the 8 other LEDs are going to light up. So we're going to have this lighting and then this lighting. So we've obviously got like a square wave output coming out of the 555, which is, you know, basically what it does. And then on the other side, as we know, we've only got the couple of components. So we've got the 1K and the 10K, which are setting the flash rate in conjunction with the capacitor. They're setting the flash rate, and also setting the duty cycle for the 555. So there we go. So final demonstration. Oh, it's coming a bit loose. Okay, there we are, one Christmas decoration. Happy February to everyone. And there we go. Thanks for watching.